Hi friends, in the previous video I was already explained the pin diagram of DAC IC. Okay, now let us see how DAC is interfacing with 8086. So in this particular video I am giving you a brief idea about in which way the 8086 microprocessor is interfacing to DAC, okay, with 8255 and without 8255. So in one part of the diagram directly 8086 is interfacing to DAC. So in other part of the diagram 8086 is interfacing to DAC through 8255. Let us see detailedly. See here, so, see the topic interfacing 8086 with 8255. Interfacing 8086 with DAC 0830 without 8255. Let us see. I will take a highlighter. Now let us see once. So this is the diagram. Here this is your DAC. The IC number 0830. We are taking DAC 0830. We know how many pins are present in DAC 0830. 20 pins are present. Okay. Now we already observed pin description in the previous video. Then here I am using one operational amplifier op-amp 741 and the reference voltage range is plus 12 and minus 12. And here I am using one motor, okay, for controlling the rotation of the motor. Then here I am using Darlington pair and here I am connecting 12 volt supply. Okay, V reference expected reference analog voltage should be in the range of plus 10 volts. Okay, then we have two grounds are present in the DAC 0830. One is called as analog ground, other is called as a digital ground. Okay, and we are using the set of address lines for controlling, and we have 8 data lines are present in DAC 0830. Like that, let us see only connection part. Let us see how it will operate, in which way we are interfacing. So coming to DAC 0830, what is first and foremost point? First we should activate CS bar signal, then only digital data is converted into analog. So CS bar, write 1 bar, write 2 bar and digital ground. All four are connected to ground, digital ground, whereas A ground is connected to analog ground. So I already explained whenever CS bar is activating, what happens? Now your DAC is ready to perform digital to analog. So whenever, what is the role of WR1 bar? Whenever WR1 bar is activating, then the digital data is loaded into input latch register. Whenever WR2 bar is activating, then the data will move from input latch register to DAC register, where digital data is converted into analog data. Okay, right? Like that we already learned. And XFER bar is a transfer control pin, and this pin is activated by the processor with the help of a set of address lines. Here we are using A0 to A7, write bar and M by O bar. All are connected to, okay, OR gate. Assume all address lines are zeros, then output of R is 0. 0 give it to XFER bar, then it will activate. Okay, so when XFER bar signal is used in order to activate actually WR2 bar, but anyway WR2 bar already we are activating, so XFER bar is also activating. Then DAC is a device and it will take digital data from the processor, whereas in this particular example without 8255 straight away D0 and D7 are the data lines, lower byte data lines of the processor are connected to DB0 to DB7 or DI0 to DI7, we can call it as DB0 to DB7 or DI0 to DB7, DI0 to DI7, both are same digital bits of DAC. So DAC receiving 8 digital bits from the lower byte of the processor. Okay, then ILE, what is ILE? It's a input latch enable. So this ILE should be connected to VCC, high. VCC means high, ground means low. So whenever high is given to ILE, what happens? It will activate. Okay, it will activate. So ILE is activating, XFER bar is activating, write 1 bar, write 2 bar and CS bar are activating. Then it will converting digital data into analog data easily. Okay, then we are converting digital data based on the bits, based on the D0 to D7 bits, we get digital data and converting it into analog output current, IOT1 and IOT2. So here IOT1 is connected to plus terminal of op-amp, IOT2 connected to minus terminal of the op-amp. So then it is connected to, plus is connected to ground. Okay, like that the operational amplifier is connected to two currents. Then RFB is a feedback resistance pin and this pin is connected to shunt feedback resistance of op-amp. Here resistance is not there, directly we can connect. If not, you can connect shunt feedback resistance to RFB. Okay, then it is connected to output of the op-amp. Okay, now VREF is the reference voltage. How much analog reference voltage we are expecting, that should be connected to V reference pin. Now here, what is the V reference pin? We are connecting how much value? 10 volts. So they are expecting 10 volts analog output from this particular op-amp. Okay, then that output is connected to transistors. Here I am connecting two transistors. They are in the form of Darlington pair. What is Darlington pair? Emitter of one transistor is connected to base of other, and collectors are connected together. Collectors of both the transistors are connected together. Then this arrangement is called as a Darlington pair. Because of this Darlington pair, it will provide driving capacity to the motor. Because of this arrangement, what happens? It will provide more driving capacity to the motor. For that reason, we are connecting Darlington pair arrangement here. Okay, so like that, this DAC will take digital data and converting it into analog data with the help of WR1 and WR2 bar registers, and that digital is now converted in the form of analog current, and that currents are passing through op-amp with the reference voltage plus 12 and minus 12. In that range only op-amp will operate. Okay, now here RFB is connected shunt feedback resistance path. B reference is the expected reference or expected analog reference voltage. Output will be connected to motor via Darlington pair for improving the driving capacity. Okay, so this is the way of connecting 8086 with DAC 0830 without 8255. Let us see with 8255 how we are connecting. See the diagram once, we can understand same diagram in an effective manner here. So here we are taking same DAC 0830, this is the portion. Here also IL is connected to VCC through resistance. Okay, then this side we reference, see the left side portion, see here. The right side portion of DAC 0830 is same as previous diagram, same diagram. So we reference RFB connected to shunt field path of op-amp, IO1 and IO2 connected to op-amp, and output will be connected to motor through Darlington pair. So this part is same. Analog ground is also connected to analog ground part. Coming to here also left side, if you observe carefully, so CS bar, right 1 bar, right 2 bar, and D ground all are connected to ground same. Whereas here how many data lines are present in DAC 8, DB0 to DB7. These 8 data lines are connected to one port. In this example, we are taking port A. Port A, PA0 to PA7 are connected to 8 data lines, DB0 to DB7. This is your 8255. In that, we are taking port A, port B, and port C. Port A, 8 pins are connected to DB0 to DB7 of DAC. Okay. Next, for activating XFER bar, in the previous diagram, we are using set of address lines. Here, we are using PB0 to XFER bar. So whenever PB0 is 0, XFER bar is activated. Okay, like that we are connecting in the right side of 8255. Coming to the left side, already we observed interfacing of 8086 with 8255. Same arrangement here also. 8255 already we have 40 pins are there. So already these three are the ports. Coming to how many data lines are present? 8 data lines are present in the 8255. These 8 data lines are connected to processor data bus, 8-bit processor data bus. Okay, then here we have two control pins, read bar, write bar, and two address lines, A0 and A1. Okay, it's a mistake. It's not A2, A0 and A1. A0 and A1. A0 is connected to A1 of processor, and A1 of 8255 connected to A2 of processor. Remember, it's not A1, A2, A0 and A1. Okay, now coming to here, M by O bar, read bar, and A0 they are taking write bar. Let us see M by O bar is now for, this is how many address lines are present? Maximum 8, A0 to A7 only. That's why this type of addressing mode is IO mapped IO, that to direct addressing mode. So this interfacing is interfacing 8086 with DAC using 8255 in IO mapped IO, that to direct addressing mode because of 8 address lines. Here 8 address lines are present. So now let us see for IO mapped IO, M by IO bar should be low. Low means IO bar we are selecting 0. Read bar for activating read operation, read bar should be low, nothing but 0. A0 is also 0. 3 are zeros, what is output? 0. 0 give it to read bar, then it will activate. Okay, then what is the operation here? IO read bar. Here we are selecting IO bar, here read bar. What is the combined name? IO read bar. Now similarly for write operation, write bar should be low, A0 should be low, and M by O bar should be low. Then we get IO write bar. Then IO write bar is given to write bar, then write bar will activate. Okay, reset of processor is connected to reset of 8255. A0, A1, A2 are connected to A0 and A1 of 8255. A0 and A1 of 8255. And here also we are using NOT with NAND, or simply take OR logic, only one OR logic instead of NOT with NAND is also correct. Here A3, A4, A5, A6, A7 all are zeros. Then because of NOT, all becomes ones. So whenever NAND gate all inputs are ones, output of the NAND is 0. 0 give it to CS bar, then CS bar of 8255 will activate. Then 8255 is ready to receive data from the processor and transmitting data to DAC easily. Like that we can interface 8086 to DAC through 8255. Okay, okay, this part of explanation I was already covered in the previous slide, right? Previous slide. same operation. Like that, 8255 can communicate to any of the devices easily. So now this video will give you a brief idea about how 8086 is interfacing to DAC device with 8255 and without 8255 in IO mapped IO, especially 8255 in IO mapped IO. Okay. I hope you understand the interfacing of 8086 with DAC device. Okay, thank you for watching this video. If you really like, please kindly share my video to your friends and subscribe my channel. Okay, thank you.